All right, guys. Now I want us to look at three things today, and bear with me and be with me, just like I shared with you earlier, that there is implicit information, important information that I need to just cover as the basics. Now, let's look at the parent graph. The parent graph we had yesterday was y is equal to x squared. And it's a parent graph because it's just like this. It didn't shift to the left. It didn't shift to the right. It is just here. It's symmetrical about the y-axis. About x is equal to 0. Okay. Now let's talk about this then. Before we come to y is equal to x squared plus bx plus c, let us talk about this. Here it is. This is y. This is y is equal to x squared. But then now, look here. Now I've taken this up. I've taken this up by y 1 unit. It's 1 unit up. Look, guys, 1 unit up. So it's the same y is equal to x squared. So y is equal to x squared plus 1. It's the parent graph just shifted up 1 unit. So that's it. That's it. Done. And then what about if it's shifted down? From there, you shift it 1 unit down. Let me shift it 1 unit down. It is still the same graph. Here it's shifted up 1 unit. Here it's shifted down 1 unit. Guess what it's going to be here? So it will be y is equal to x squared minus 1. Done. Now let's look at this one. This one was, let me use maybe black pen. So this one was y is equal to minus x squared. Why? Because our a there is negative. So it said, so that is y is equal to minus x squared. What about if I move it up? So I've taken the same graph, I move it up 1 unit, right? Y, x. So it is going to be y is equal to minus x squared plus 1. But do you see here? That means it has roots there. Here it has 1 root. And then what about this one? That's going to be like that. At that point, minus 1. So that will be y is equal to minus x squared minus 1. So you see, you're shifting up and down the parent function, the quadratic function, and then we're starting with the parent function. Okay, now let's talk about the tangent to a curve. I'm talking about something different. The tangent to a curve. What is a tangent, first of all? A tangent is a line that touches a curve at one point. That is a tangent. That line is called a tangent. So this could be a circle. This could be a graph. As long as it touches a graph or a circle at one point, it's called a tangent. But then now let's talk about a tangent to a curve. Tangent to a curve. There is my point there. Is point A. And if I want to draw a tangent to this curve, I'm going to draw a line that is going to touch There can't be many lines that are going to touch this tangent here, right? Or that are going to touch this curve at point A, right? So here, you can have another point B there as well. Point B, so the tangent to point B, so that means there's only one line that is going to pass there. So that is it. What about, you can have point C there. So Point C, tangent to point C, that means that would be tangent to point C. Okay, let me use a green pen. Tangent to point C, right? So what do I mean, tangent to point C? That line that touches point C at, the curve at one point, and that point could be C, could be A, could be B. And you can have a tangent there at point D. You can have a tangent right there. And that would be, if I want to draw a tangent there, that would be like that. A line, it's a straight line. That would be a straight line. Forgive my line, okay? But then it's a straight line that touches a curve at one point. Now, let us move on to this one. So, whatever graph this is, we know that it's a quadratic graph. It is a quadratic graph. So now, the question is, by drawing a tangent to the curve, x is equal to 1. By drawing a tangent to the curve, x is equal to 1. Find x is equal to 1, x is equal to 5, sorry. By drawing a tangent to the curve, let me change the question. Find the gradient when x is equal to 1 and when, x is equal to 5. All right, so now we need to draw a tangent. Look here, at x is equal to 1, if I'm going to move up there, moving up, at that point, there is only that point there from x is equal to 1, so there is the point there. So now what am I going to do? I'm going to draw myself a tangent from there. A tangent, use a ruler, okay? So when I do that, it's going to be like that, and now I need to draw a line, but then as you know that you can only find m is rise over run, right? Which is delta, or the change in y over the change in x, right? So you need to have this side. Now you are going to draw a triangle. There is my triangle there. And why am I drawing this triangle? So that I can find the distance there. The distance there is 3. And then what is the distance there as well? The distance there is 3. So what is the change here? The change is 3, rise over run. So if I'm going to rise there and run that way. So it's going to be rising up, positive, but running negative, so which will be -1. So that will be the gradient here. And you know that your gradient is like this, it's negative, right? So now let's look at the second one. This one says when x is equal to 5. So that means here, when x is equal to 1, when x is equal to 1, so that is the gradient. What about when x is equal to 5? So that means I'm going to go up to 5, from 5, I'm going to go up, approaching the curve. At that point, I'm going to draw a line. And what am I using? I'm going to draw a line like that. But I'm making sure that at least I will have the distance there and the distance there that can be defined. You cannot just end it here, right? So you have to end it, at least here I'm ending it right on top of 4, and I'm ending it there right on 4, and I'm ending it here at 7. So now, what will be your distance here? Your distance from 4 to 7 is 3. And your distance from here I can see that there is 1, and at that point it's 4. So 4 minus 1. So this distance, 4 minus 1 is 3. 4 minus 1 is 3, yeah. So in this case, it is 3. So the distance here is 3. And obviously, I'm using the board, so yours could be different, okay? So here, what will be the gradient here? So your gradient is the change in y, rise over run. So it's 3, it's positive, right? It's positive. So it's 3 over 3. Run 3, rise 3, run 3, so which is positive 1. So these would be my answers here, okay? So when x is 1, that's the gradient. When x is 5, that's the gradient. But take note of these two triangles that I draw here. Okay, so thank you very much. I'm going to give you more for you guys to practice. Don't forget, you can replay this this video time and again. All right, bye.